So basically, I've wrote my own GitHub. Before telling you more about this project, I think I should talk about why I decided to do it in the first place. Have you heard about sourcehut? Sourcehut is a Git hosting provider run by the man called Drew DeVolt, and I have a one-sided personal beef with this man in the sense that I know who he is, but he doesn't know who I am. Sourcehut is really great. The software is very good, but in my opinion, Drew DeVolt is a fucking asshole, so that makes it very unfortunate. I don't know about you, but I would much rather the software I use not controlled by those kind of people. So naturally, I do the things that every single software engineer who knows his tricks will do, which is to write my own version. Okay, so now I'm going to demonstrate how Aegis looks like in the current stage of things. So we have here an hypothetical VPS running Debian as a virtual machine. We have set up the port forwarding so that whenever any server inside the virtual machine listens on these ports, we can access them in the host with these ports. If we SSH to the local loopback address with this port, we should able to SSH to the guest server here. So we can do this. As you can see, this is the Debian virtual machine. The deployment is very simple. After you have built from the source, you just copy it over to the server. Here we will use SFTP. And now we copy the executable over to the home directory of the Git user. We now execute the executable. As you can see, it asks you if you want to start the web installer. Currently, the web installer only generates the config file for you. You have to do extra things to actually set up the database and all the other stuff. I'm planning to fix this in the future. So now we start the web installer. Now we choose 8000 so that we can access the web installer using the port forwarding. So now if we start Firefox and if we do this, we can see here the web installer. We can now follow all of these steps. After the web installer, we should see a page that looks like this. After this, we can stop the web installer. After this part, we need to run the Aegis executable using the newly created config files again. This step does a lot of things like setting up the database and creating an admin user. It will report the admin user's password here. We don't need to take note of that because I have provided a command that allows you to reset the password of the admin user anytime you want. Of course, we are running using the root user up to now, so before actually running the web server, we should change the owner of everything we have created to the Git user. So now you can see there won't be any permission error if we run the web server using the Git user. Then we can run this command that starts the actual web server. And we can get access of this server here. We currently don't create the corresponding namespace whenever a user registers, and I'm thinking about changing this behavior in the future so that whenever a new user registers, he will have his own namespace immediately. We now log in using the admin user. We get to the page to create a new namespace by using this pop-up menu or by using the setting, which contains a link at the left sidebar. So we would name this admin and we'll title it admins. So within this namespace we can create a new repository. So now we have created the repository. We now need to set up our SSH keys so that we can push our local repo into the remote. So we now just copy this and we copy this over. So now if we go back to the repository, we can randomly take a repository, like for example the Aegis repository itself. We can add the SSH remote to the address it provides, and we can just git push eu test. And after doing that, we should be able to see the updated thing here. So Aegis can automatically detect any readme file in the master and then the main branch, and it displays it here if it is a markdown file or any other file. So we can go to the master branch here, and we now have a file tree here. We can navigate among the different files and select a random files here. Or we can randomly select a file and see that it is all syntax colored. We can now clone this repository using either the HTTP address or the SSH address. So we now go to the git clone. Sorry, HTTP is a bit wonky right now, so but if we use SSH, this should be working. And you can see this, the repository is here. And if we add our changes here, we can push and it will show up in here. As you can see, we have created this file name blah, and this is the content I have randomly typed before. And you can see the branch, the master branch now points to the new commit we have just created. You can also see the diff of this commit, which is very small, and the full history of the, not full history because that will be very long in some report which has very long history. So we display only an amount of them, and we have this older commit button here. Aegis support issue, but Currently, this feature only works like a built-in board or a guest book. You can create a new issue and comment on issue and close or reopen or close as sub or this kind of stuff. I'm planning to add more things to it in the future. Another thing I want to demonstrate here is the ability to do pull requests. But before creating a new pull request, we should first fork the repository. You can see that there is a part in the header which shows that this repository is a fork of this other repository. And if we clone this, and do some changes here, we can see the changes in our forked repository. And if we go back to the source repository, we can create a new pull request to use this fork and use just whatever branch we chose in this fork into this branch of this source repository, and we can select master and we can write the title for the pull request. And as you can see, we have here 3 options. One is to post comment. This is just simply posting comments. The second option is to merge check. This does not merge the pull request. This only performs a check. And the third one is simply calls the pull request as not merged. And we can reopen it. And because there is no merge check result, we cannot merge and close this pull request yet. So now we perform the merge check. So now you can see the check is successful. So another option is now displayed and we can merge and close. And this will show you that this merge request is merged and there is no longer any option other than you can post new comments. If we go back to the master branch, we now have a new commit. If we open the changed file, it is now the new changes. And if we check the full history, we can see the change in the forked repo. See, it's now combined within the history. Now we will create a scenario where the merge check will fail. We go back to the forked repository. There is a feature missing here, the feature of syncing the original repo to the forked repo. I'm now very busy with other stuff, so I'm planning to solve this problem after that. Now we will create a different commit in both the original repository and in the forked repository. Now we can see that the changes in this forked repository and the changes in this original repository is different. And if we create a pull request now and perform a merge check, it will show you that the merge check has failed, and it will show you that this file has a merge conflict and you must resolve this. So currently you have to manually merge from the forked repo and do all the things you need to do manually. After resolving the conflict, we now proceed to commit the result. And now we push. And if we Perform the merge check again. This time it will show as successful, and we can merge and close as merged. First question, did you use libgit too? No, Aegis does not use libgit too. When I first started the project, I didn't know there was libgit too, so no. All the Git related actions are done either by directly reading the Git folder or by executing the Git command. Question 2. Did you use AI? Currently there are about 25,000 lines of code, and I wrote every single line of them because I was too poor to afford AI coding tools. Question 3. Why is your code so bad? Well, this is my first Golang project, and I have never learned Golang before, so it may not be the very best of Golang code. This is also my first web backend project that goes this far and becomes this big as well. I've written a few small ones in TypeScript with Node.js and in Python, but nothing too serious. Question 4. Why did you choose Go? I chose Go for two reasons. The first reason is that it is one of the languages that people actually hire. If I already had a job, I would probably write it in Nim. I made a web framework for Nim a few months ago. It would be a good idea to put it to the test. The second reason is that I also intend this project to be a showpiece I can use to tell people that I can indeed learn on the job despite what everyone else would have said. So the fact that I never learned Golang before is very important. Now that I think about it, I should probably write it in Java using Spring, but I don't think that not knowing Java and not knowing Spring is necessarily a good look in this job market. So, question 5. What is your verdict on Go? It's a tolerable language. I wouldn't say it's well defined, but it is tolerable. The thing about Go is that it makes simple things simple to do, but it didn't make the correct things simple to do. And it feels like to me that because they have made the simple things simple to do, they thought they have already achieved simplicity, so that when the correct things comes along, either in a complex or in a simple form, because the most simple form of the correct things might have been more complex than the simplicity they have already achieved, the Golang people, out of their fear of breaking that simplicity, refuses to let the correct things being incorporated into Go. We all know there's a lot of questionable design decisions in Golang, like how it didn't have generics until very late, it didn't have some types, it didn't have a lot of things. And that mentality, I think, it is very bad. It is not good. This is the main gripe I have with the language. Question 6. How do you implement push by SSH? Aegis currently use the same trick as Gitelite. The way you do this is to put the user's SSH public key alongside with their username in the authorized keys file. That file, you can specify which command to run according to the public key used to log in. You can tell which user it is by passing the username as a command argument to a custom command, and that's how you can implement all kinds of access control there. Question 7. How do you implement pull request? The thing about pull request is that it is not a part of Git. Merging is a part of Git, but pull request isn't. So the most basic form of pull request is, first of all, you have a provider branch and a receiving branch. The first step is to set up a remote pointing to that provider branch in the receiving branch, and then you execute git fetch to grab that providing branch into the receiving repo, and then you execute git merge tree to merge the two branches, git commit tree to create a commit object around that tree object, and then you execute git update ref to update the reference of the branch to that newly created git commit. So that's the most basic form of a pull request. Question 8. What's the next step after this? So as for Aegis itself, I have a list of 20 something features, and I plan to implement them one by one in the future. As for anything else, I am going to try to write a key value store like Redis from scratch, because I made it a personal policy that I should use as little projects that uses the contributor covenant as possible. And if I completely ban contributor covenant in my own choice of persistent key value store, I basically have nothing left unless I want to use SQLite in that way. That is not a situation that I want to be in. So I will try to fix that. So that's it for now. If you have any more questions, you can put it in the comment section below, and I will see you next time.